Good morning everyone, good morning all the students. How are you all? I'm also fine. This is Prema here. This is my channel SciMa Academy, and today I'll be starting up with the science chapter. Okay, so I'll be taking up the structure of atom, which is one of the most important chapters of grade 9 chemistry. And I found that from my students and other students, I found that this chapter is little tough for them. They are finding it little tough to understand. So that's why I chose this chapter to explain it to you. Okay, so take your notebook and your pen, and you can pause the video in between to take up the notes, because I'll be presenting the video, I'll be explaining at the same time. Simultaneously you will be taking up the notes also. This will help you in your exam preparations, okay, as exam is nearing, and you can make notes also out of it. Okay, so don't forget to subscribe to my channel, that is SciMa Academy. I'll be coming up with more videos in front of you. So let's start with the chapter. So you have to also learn about the discovery of neutrons. Okay, so Chadwick discovered the third subatomic particle, that is neutron. Okay, neutron. Okay, and this neutron will have no charge. It doesn't have any charge, and its mass is equal to the mass of protons. Okay, so neutrons are present in the nucleus. So if we have the nucleus here, so protons and neutrons are present inside the nucleus, except the hydrogen atom, because hydrogen atom atomic number is 1, so it is having only one proton. Okay, so 0 neutrons, it will not have any neutrons. Okay, so the mass of atom is therefore sum of protons and neutrons in the nucleus. So whatever mass of the atom is because of the protons plus neutrons. That's why protons and neutrons are also called as nucleons, because they are present inside the nucleus. Okay, and the electron will be revolving around the nucleus. So subatomic particles, we have electrons, protons and neutrons, which is comprising the atom. Proton mass is 2000 times of electron mass, so electron mass is considered as negligible, and proton and neutron have mass of 1 unit. Okay, so both proton and neutrons have the same mass. Now coming to the next topic, that is atomic number, mass number and isotopes and isobars, which you have to learn. Okay, so atomic number we denote it by the letter Z. Okay, it is nothing but the number of protons in the nucleus. How many number of protons are present in the nucleus? Okay, which is the atomic number. Okay, so all the atoms of the element have same atomic number. So whatever atoms in that, suppose carbon is an element, all the atoms of the carbon will have the same atomic number. Okay, that is 6. Hydrogen atomic number is 1. So elements are defined by the number of protons they possess. That is nothing but the atomic number. Okay, now mass number is sum of protons and neutrons. Okay, so sum of protons plus neutrons makes the mass number in the nucleus. So they are present inside the nucleus. Okay, so mass of an atom is present inside the nucleus. Whatever mass of an atom is concentrated in the nucleus. Okay, because electron's mass is negligible. Electron doesn't have any mass. So whatever mass of the atom you see is because of the combined mass of protons and neutrons. Okay, so the carbon has suppose 6 protons and 6 neutrons, so its mass will be 12 units. Suppose if you have sodium atomic number is 11, so its mass number is 23. So I can find out P plus N is the mass number, right? So I can find out the number of neutrons in this. So protons are 11, mass number is 23. So we can find out 23 minus 11, that is 12. So we can find out the number of neutrons present in sodium. Okay, so this way, if mass number is given to you or atomic number is given to you, we can find out the third entity here. So when you notation of the atom, how do we represent? So when we write, so this is the symbol of an element, and we write the atomic number at the top and mass number here. Okay, so X atomic number we denote by Z, and mass number we denote by A. Okay, so this is Z and this is A. So if I have to represent say carbon, I'll write the symbol of the element, I'll write its atomic number 6 and its mass number 12. So this is how we represent any element showing the atomic number and the mass number. Now coming to the next topic, that is isotopes. Okay, so isotopes are the elements having, they are actually the elements having same atomic number. They are same elements basically, they are having the same atomic number but different mass. Okay, the best example you have hydrogen isotope. See, if you see here hydrogen, here this is protium, this is deuterium and this is tritium. Okay, a protium has only one proton, which is having only one proton, that means atomic number is 1 and 0 neutron, whereas deuterium is having so deuterium is having one proton and one neutron, and tritium is having one proton and two neutrons. So if you see here, it's the same element with atomic number 1, that is hydrogen, but what is differing here? Here 0 neutron, here is 1 neutron, and here is 2 neutrons. Okay, so here what will be the mass? Mass will be 1 plus 1, that is 2. Here mass will be 1 plus 2, that is 3. And here mass will be 1 plus 0, that is 1. Right? So here if you see, masses are different. Atomic number is the same atomic number 1, 1. But the mass numbers are different. Okay? So such elements, they are atoms of the same element having same atomic number but different masses. So isotopes will have similar chemical properties because they have same atomic number. Okay, but they have different physical properties because they have different mass. Okay, so that's how when we want to find the average, so now the atomic mass of suppose chlorine. Now here they give you example, example of carbon also. Carbon isotopes, you have carbon 12 and 6 and carbon 14 and 6, right? And chlorine also you have 35, 17 and 37, 17. So these are the two isotopes of chlorine. So here if you see, the neutrons will differ. So when you see the isotopes, they have different neutrons. The protons will be same but neutrons will differ. Here you can see carbon is having 6 neutron, 8 neutron here, and here chlorine 35 has 80 neutron and chlorine 37 has 20 neutrons. Okay, so when you have isotopes, their atomic mass cannot be a single number, right? Now atomic mass we can't consider as 35 or atomic mass we can't consider as 37, because in nature they are present as different percentage in nature. So if you see chlorine, they are present in the ratio 3:1. Okay, chlorine 35 and chlorine 37. So in the nature they are present, the isotopes are present in the ratio 3:1, that is 75% and this is 25%. Okay, so how do we find the atomic mass? So here what we have to do is we have to find the average atomic mass. Okay, average atomic mass we find in case of isotopes. Okay, so but if there is a normal element, suppose carbon, you can say suppose sodium. Okay, now sodium atomic mass will be equal to the number of protons or neutrons. Okay, there is no need to find average atomic mass. But in case of isotopes, since the isotopes are present in different composition, different percentage, we have to find the average of that. Okay, so how do we find average of that? We will take the average atomic mass, we will write the percentage, how much percentage of this isotope with atomic mass 35 plus 25% of atomic mass 37. Okay, so here we have to calculate 35 into 100, 35 plus 25 by 100 into 37. Okay, so if you calculate, you will get 35.5 units. So that's why the average atomic mass of chlorine isotope or chlorine will be 35.5 units. So here if you see, it's calculated same way how I did. So you get average atomic mass of chlorine as 35.5 units. That means, it doesn't mean that there is any single chlorine atom has this. It is nothing but it is average of all the atoms of chlorine, because when you take an atom of chlorine, it is having both the isotopes in that. So we have to find the average atomic mass of chlorine or any other isotopes present. Okay. So here they have given you about certain applications of isotopes. So isotopes has several applications in medical field also. In nuclear energy concept, isotope of uranium. Okay, isotope of uranium is used as a fuel. Okay, in the nuclear reactors, it is used as a fuel and providing energy through controlled nuclear fission reaction. It is used as a fuel in nuclear reactors, which is used to generate electricity. Okay. Cancer treatment also, isotopes of cobalt is used in radiation therapy for cancer patients. Okay, targeting the cancer cells. Okay, targeting the malignant types of cells. And medical also, in medical field, isotopes of iodine is used in the treatment of goiter. Goiter is a vitamin D deficiency disease. Okay, and also thyroid disorders also. It is treated using isotopes of iodine. So last concept is about isobars, which is different elements. Okay, they are different elements but they have same mass. Like example, they have given you calcium and argon. Now calcium is atomic number 20 and argon is atomic number 18. But you see their mass number will be 40 and 40. So what will happen? The number of protons are different, right? The number of protons are different. Their mass number is same, right? Proton here is 20, your proton is 80, but mass number. Now if your neutrons will also differ, right? So they have same mass number but different atomic numbers. So neutron here will be 40 minus 20, that is 20. Your neutron will be 40 minus 80, that is 22. Okay, so here number of neutrons will differ, protons are also different, but the mass numbers are same. Okay.